Hello there, Mr. Sutton here, bringing you the Algebra 2 Honors 3-1 Part 2 homework solutions on solving quadratic equations. This one we're focusing on the technique of factoring. For this first problem, solving this equation, it's tempting to divide everything by u, but we might be dividing by 0 if we did that. So instead, we're going to zero this out and try to factor this using our zero product property to get our answers. So we can take a u out of this. I always look for common factors before I do anything else. So taking out a u, that leaves us with u plus 9. And then zeroing each of those out, we have u equals 0 for this little stray u out here. And negative 9 plus 9 is 0, so that's our other answer here. To solve this one by factoring, we're going to use the a squared minus b squared shortcut, where you basically square root each of these and put them in a plus minus parentheses. So square root of a squared is a, square root of 49 is 7, so we have a plus 7 and a minus 7 equals 0. And then zeroing each of those out, negative 7 plus 7 is 0, so there's one answer. And then 7 minus 7 gives us the 0 for the other answer there. Now, you could have done this if you didn't have to use factoring. You could have also done this by adding 49 and then square rooting both sides. Just remember that plus or minus when you square root an equation. For this problem, they want the 0 of this function, so we will start before anything else by setting this thing actually equal to 0. And now we'll solve it. Probably could solve this by factoring. Now, I could think of numbers that multiply to 121 and add up to 22, but I noticed that x squared and 121 are both perfect squares, so I might be able to use this a squared plus 2ab plus b squared sort of shortcut that becomes a squared parentheses. So if that's the case, then I just need to square root the first and last terms and test it out after I try it. So the square root of x squared is x, square root of 121 is 11, and the middle sign here is positive, so this might be x plus 11 quantity squared equals 0. It might be. I don't know for sure, though, until I actually test it out. To do that, I just multiply these terms together and then double that to see if it matches the middle coefficient in the beginning. X times 11 is 11x. 2 times that is 22x. So that does match. This is the correct factorization. Now, I just have to set this equal to 0 and solve it. Negative 11 plus 11 equals 0, so that is our answer. On this problem, we're trying to find the 0 of the function, so let's set this whole thing equal to 0 as a starting step. And then after that, we're going to try to factor the left side so that we can use our zero product property. Now, since a does not equal 1, things I always look to do in that situation is take out a common factor. It doesn't look like there is a common factor that I could factor out or divide by. So the next thing I look at is if there's any shortcuts. You know, kind of the last ditch effort is to use the AC method or guess and check. But if there's a shortcut, well, obviously that will be faster than those other things. 4x squared and 9 are both perfect squares. So I'm thinking this might be this shortcut here, where you can factor it into that squared parentheses. If this is the case, then the square root of 4x squared would be 2x, the square root of 9 is 3, and the middle sign is negative, so this might be 2x minus 3 quantity squared. It might be. Again, we always have to check this shortcut because this 2ab, we can't really predict whether this number here is actually 2ab by just looking at the first and last terms. So if I multiply 2x and negative 3 together and then double that, that does give me negative 12x. So this is good. So let me just set this equal to 0 and solve now. So if 2x minus 3 equals 0, I can add 3 to the other side and have 2x equals 3. And then I just have x equals 3 over 2, or 3 halves, for my final answer. On this problem, we're trying to find the 0 of this function. I'm going to start by setting this equal to 0, and now I'm going to try to solve this by factoring. So I noticed that we have an a value right here that's 2, it's not 1. So let me see if there's a common factor I can take out before I do more extreme factoring techniques. It looks like all of these are divisible by 2. So let me actually just divide everything by 2. I could factor a 2 out, but since it's a constant, I'm safe just dividing by it. So I've got then x squared minus 1x minus 6 equals 0. And this is more of our traditional old school easy factoring situation here. I'm just looking for things that multiply to -6 and add up to -1. So 1 and 6 doesn't work. 2 and 3 works if I have +2 and -3. So we have x plus 2, x minus 3 equals 0. And then just zeroing each of these out, -2 plus 2 is 0, and 3 minus 3 is 0. So those are our answers. To solve this equation by factoring, I have to first zero it out. I can't use the zero product property without a zero, right? So now that I've done that, I notice that my a value in front of the squared term is not 1. So I'm going to have to use some other kind of factoring technique. Let me think about common factors. Is there something I could divide all these by? Doesn't look like it. There's no perfect square kind of shortcuts I can use here either. So that really just leaves me with guess and check or the AC method. I'm going to use the AC method. So 3 times -4 gives me an AC value of -12. And then things that multiply to -12 and add up to 11. Let's see, 1 and 12 works if I have a -1 and a +12. So let me split this 11p up into a -1p and a +12p. Now that I've rewritten this with 4 terms, I can factor it by grouping. Looking at my first 2 terms for common factors, I can take a p out of these first 2. That leaves me with a 3p minus 1. And for 12p minus 4, I can take out a 4 from both of those, leaving me with 3p minus 1. 3p minus 1 is my common factor that I can take out of everything now, and then I'm left with p plus 4 as the other factor. Now that I've got it factored, just set each of these equal to 0 and solve. If 3p minus 1 equals 0, then 3p equals 1. I can add the 1 over there. And then just dividing here, I get p equals 1/3. And then -4 plus 4 is 0, so p equals -4 is the other answer. On this problem, they are trying to have us zero out this function. So we just need to set it equal to 0 and solve for x. Since a is not 1, let me look first at common factors. It doesn't look like there are any common factors. So the next thing is perfect square shortcuts, but it doesn't look like we can use any of those either. There's no perfect squares at either end. So we'll use the AC method then. You could use guess and check. I think AC is a little faster on this one though, depending on how lucky you are. So our AC value, 8 times 6, gives us 48. Numbers that multiply to 48 and add up to -19. Let's go through our possibilities. 1 times 48 doesn't work. 2 times 24 doesn't give us 19 if we add those. 3 and, let me think, 16. Yep, I can get a -19 out of that if I have -3 and -16. So I'm going to split this -19x up into a -3x minus 16x. And now that I've done that, I can factor this by grouping since I've got 4 terms. For my first 2 terms, I can take an x out of those. That leaves me with 8x minus 3. For the last 2 terms, -16x and 6, I can take a -2 out of those, leaving me with an 8x and a minus 3. This 8x minus 3 that they have in common can be taken out as its own factor, and that leaves us with x minus 2 as the other factor. All right, so now that I have it factored, I can just set each of these equal to 0 and solve for x. 8x minus 3 equals 0, so 8x must equal 3 then. And then we can divide by 8 to get x equals 3/8. And then over here, 2 minus 2 is 0, so x equals 2 is our other answer. For this last problem, we have an athletic store charging $120 per pair of basketball shoes. Sounds like a lot, but that's pretty standard these days, I guess. And then selling 200 pairs per month. Now, they figured this out through some kind of market research that for each $2 increase in price, the store sells 2 fewer pairs of shoes. And then we want to know how much should the store charge to maximize monthly revenue, and what is that monthly revenue? So the thing that we're changing here is the number of these $2 increases. So let me let x equal the number of price increases. And we're going to write a function to describe the revenue of this thing. Revenue is going to be the price times the number of shoes sold. So we're going to create an expression for each of those using this x here. So for the price, we're starting with $120 and we're increasing it by $2 x number of times. So we can write 120 plus 2x, and that will give us the price after however many increases we want to do. Now we also have to multiply this by the number of shoes sold. Initially that was this 200 here, but we're losing 2 shoes every time we increase the price. So 200 minus 2x would tell us how many shoes we actually end up selling then. And at this point we're going to try to maximize this function. So this is an intercept form quadratic sort of function. The fastest way to figure out the max of these is to get the x-intercepts and use those to find the vertex, because the max happens at the vertex of our parabola. So let me set this equal to 0 and solve using my zero product property now. I actually don't have to do any factoring now. So 120 plus 2x equals 0. So we can say 120 equals negative 2x. And then dividing by 2, we have x equals negative 60. And then 200 minus 2x equals 0, so 200 equals positive 2x, which means that if we divide by 2, we end up with x equals 100. In terms of real life, these are the number of increases that would cause us to have a zero revenue. The negative 60 basically would zero out your price part here, so you'd be selling your shoes for free. So clearly you would get no money for doing that, however many people bought them at that price. And then this 100, that zeroes out the number of shoes sold. So if you increase the price by $2 100 times, nobody's going to buy your shoes. So again, your price doesn't make a difference. At that point, you've zeroed out the revenue. Now to get the max, let's average these together to get the vertex. So negative 60 plus 100 over 2, that's negative 40 over 2, which is negative 20. Or actually, positive 40 over 2, which is positive 20. There you go. Too bad it's not negative 20, then we could have gotten cheaper shoes. But alas, this is telling us we have to increase the price by $2 20 times. So when we're asking for the how much the store should charge, we can't just say, hey, it's 20. We actually have to put that back in this price sort of mini function here. So it's actually 120 plus 2 times the 20 that we just found. So 120 plus 40, so $160 is the sweet spot that will maximize our profit. And then to get the actual revenue, we have to plug this back into the whole function here. And I could maybe reason this out in my head, but I'm just going to plug this into Desmos so I don't mess it up. And since I am using the power of the Desmos scientific calculator, I'm actually going to do this by just rewriting this function and then plugging 20 into it. Then I don't have to worry about all these parentheses going on. So we've got f of x equals 120 plus 2x, and then 200 minus 2x. Let me make a new entry now, and I'm just going to put in f of 20, and then that gives us 25,600. So that is our revenue when we have maximized it.